Here we'll get some practice writing polynomial functions from a graph. Part A asks us to find the zeros and their multiplicity based on this graph. On this graph, we're going to look for the x-intercepts. On our graph, we have three x-intercepts. This dot at -1, 0, this other dot at 3, 0, and this final dot at 5, 0. In order to begin writing our polynomial, we'll first write x equals each of those x-intercepts. So we'll start with x equals -1, x equals +3, and x equals 5. We'll now set each of these equal to 0. Since we want 0 on the right, we'll need to do the opposite of -1 on both sides of this first piece, and we'll add 1 on both sides. If we have x equals 3, let's now subtract 3 from both sides to make sure we get 0 on the right. And from our final piece, we'll subtract 5 on both sides. If we do this operation to our first piece, we'll end up with -1 plus 1, which is 0 on the right, and then x plus 1 on the left. We end up with x plus 1 equals 0, and once we get here, we can note that x plus 1 will be our first term in the polynomial we write. We'll say y equals, we'll leave ourselves a little space, and we'll say x plus 1. Now we also looked at the multiplicity. For our multiplicity, we look at the shape the graph makes at x equals 1. Here at x equals 1, we can see the graph flattens out as it crosses and then begins to increase rapidly again, but it stays flat for a short period. I'm going to call this a squiggle. And when you have a squiggle on your graph, that is third power or multiplicity 3, which means that when we write it in our polynomial, it will be third power. We'll place that 3 as an exponent on the x plus 1. So at least now we know our polynomial must contain x plus 1 raised to the third power. We'll now do the same thing to our second piece. Starting with x equals 3, we're subtracting 3 from both sides, and we'll get 0 on the right and x minus 3 on the left. If we consult the graph, we can see that at x equals 3, we are crossing straight through. If you're crossing straight through, that means that 0 is a first power or multiplicity 1. This will mean x minus 3, when we write it in our polynomial, will be first power. Therefore, we'll write x minus 3 as the next term for our polynomial, and if you like, you can place the invisible 1 above it. We repeat that process with x equals 5. Subtracting 5 from both sides gives us 0 on the right and x minus 5 on the left. Again, we consult the graph, and we can see the graph crosses straight through at 5, meaning that is multiplicity 1 or first power. Based on that, we'll say x minus 5 as our final term in our polynomial, and if you like, we can place the invisible 1 on it. The only thing missing from this polynomial is a leading coefficient. We don't know what the leading coefficient is yet, so we'll place an a in front. To complete writing the polynomial, we'll have to find what a is. To find a, we'll have to substitute something in for the y and all of the x's. For this, we'll have to find another point on the graph. We'll have to pick one that's easy to read in order to be able to calculate this properly. Trying to approximate this may lead to some errors, so let's look for a point that's fairly definitive. Oftentimes, your best choice for this will be the y-intercept. We can't reuse any of the x-intercepts, but now we can look to the y-intercept to help us plug in for x and y. Our y-intercept is 0, 3. So let's look at what happens if we let x equal 0 and let y equal 3. If we replace the y with 3 and the x with 0, we'll have 3 equals a times 0 plus 1 to the third power times 0 minus 3 to the first power times 0 minus 5 also to the first power. We'll have to simplify all this math. We'll still have 3 on the left equals a times 0 plus 1, which is 1, raised to the third power is 1. Then times 0 minus 3 is negative 3, and 0 minus 5 is negative 5. If we multiply all this together, 1 times negative 3 times negative 5 will give us positive 15. We'll still have 3 on the left, and now we'll have 15a on the right, because you can write the 15 and the a in any order. Now to solve for a, we'll divide by the number in front of a, which is 15. When we divide by 15, we'll have a equals 3/15. And if we reduce this to lowest terms, this will be 1/5. Finally, to write the polynomial, we'll say y equals 1/5 times x plus 1 to the third power times x minus 3 times x minus 5. This is the completed polynomial based on this graph.